Atoms are neutral. By neutral, we mean they have no electrical charge. They do not have a positive charge. They do not have a negative charge overall. But in order for them to be neutral, they have to have an equal number of positive charge to negative charge in order for them to cancel out. So take a look. If you have a +5 charge, the only way you can make this a 0 is if you minus a 5, or if you have 5 plus charges, positive charges, you need 5 negative charges in order for them to cancel out. So if you see here, I always like to draw representations because that really makes me understand science as a whole better. So feel free to always sketch your own representations to understand things. So here's 5 positives, 5 negatives. The outcome is 0. The outcome is 0. So there are two important numbers that you have to remember. The terminology is very critical here. The first number is called the atomic number, and that's the symbol Z. And it's the number of protons. And this number is very important because this one determines the identity of an element. And this number does not change. So all atoms of an element have the same number of protons in the nucleus. This is what distinguishes atoms of a given element from atoms of another element. Very simple. If we look at carbon, carbon has 6 protons. Oxygen has 8 protons. So if you change the number of protons in carbon, you will change the entire element, the whole element. So if we add, for example, 2 protons, then that element turns into oxygen. But we're not going to be concerned with this now because this is more in the nuclear physics realm. Majority of chemistry occurs with the electrons on the outside. Now, the mass number A is the number of protons and the number of neutrons. Now, the number of protons, as we said, is fixed. It does not change that number, but the number of neutrons is not. So the number of neutrons can vary. We want to look at the isotopic notation. This is a way of representing the mass number and the atomic number that are related to that element. So you have X, imagine this is the chemical symbol, and then you have A on the top, that's the mass number, and you have Z on the bottom. That's the number of protons. And what we want to do is we want to be able to do simple calculations of calculating how many protons, neutrons, and electrons you have in the atom. Now, before we begin, you need to recall that for atoms, and when we say atoms, we always mean neutral. For atoms, you have an equal number of protons to electrons. So this number right here, Z, is equal to the number of protons, which is also equal to the number of electrons. So your work is cut out for you here. That's the number right here is the number of protons, and an equal number of that is the number of electrons. So let's take a look. Now, for the number of neutrons, you have to take the number on the top, A, since it's the sum, and subtract the number of protons to get N, the number of neutrons. Again, this is a sum, and this is just the number of protons. So let's take a look. You have phosphorus, 31 here, 15 on the bottom. So let's begin with the easy stuff. So this number right here on the bottom, that's the number of protons. So we have 15. Remember, this is also equal to the number of electrons. It's 15, since the atom is neutral. Now, the number of neutrons is simply 31 minus 15. And that gives us 16. So what's a common mistake is that students think that the top number is the number of neutrons, so they write 31. That is not correct. Remember, that's the mass number, and it's called the mass number because it gives that atom its mass. Neutrons and protons are much more massive than electrons. Now let's look at another example. What we have here is we have an element called yttrium. That's how it's pronounced. The symbol is Y. And this is an interesting element, especially this isotope, and we'll talk about isotope in the next page. On the next page, Yttrium 90 is used by radiologists to actually kill cancer cells in the liver. And it is, if you notice here, there's always this section in the hospital called the nuclear medicine, because again, it uses what we call radioactive isotopes and their radiations to kill cancer cells. So let's look at yttrium 90. So number one is that the protons is right there. That's Z. So that's the number of protons and electrons. So that's 39. The number of electrons is also 39 since the atom is neutral. And then, of course, for the number of neutrons, we take 90. This is A. Okay. So the number on the top, as we said, right there,